Have you ever wondered if you could unbake a cake? I mean, you mix egg sugar, throw it in the oven, and boom, you've got cake. But what if you wanted those ingredients back? That's basically the big question behind reversing chemical reactions. And today, I'm diving into the wild science of going backwards. First off, not every reaction is created equal. Some are reversible, like when water turns into ice and back again. That's just a physical change. But a chemical reaction, like burning wood, feels pretty permanent. Or is it? Here's where things get cool. Chemists actually use something called the reverse reaction all the time. In fact, the entire idea of chemical equilibrium is built on reactions going both forward and backward. Let's take an example. Making ammonia in the famous Haber process, nitrogen-hydrogen combine to form ammonia. But under the right conditions, ammonia can split back into nitrogen and hydrogen. This back and forth is happening constantly in a sealed system. It's like a molecular tug-of-war. But wait, what makes a reaction reversible or not? It's all about energy. If the products have more energy than the reactants, reversing the reaction is possible, but it might take a ton of effort. Think heat, electricity, or even light. That's why you can recharge a battery. You're literally forcing a chemical reaction to run in reverse. That's science magic, people. But let's get real. Some reactions are basically one-way streets. Burn a log, and you're left with ash, carbon dioxide, and water vapor. Getting that log back? Not happening with today's tech. The energy required and the complexity of the molecules make it impossible. For now. Still, scientists are getting creative. There's a whole field called green chemistry, working on designing reactions that are easier to reverse, meaning less waste and more recycling. Imagine if we could uncook plastic and turn it right back into brand new plastic over and over. That's the dream, and we're getting closer every year. In the end, reversing chemical reactions isn't about breaking the laws of physics. It's about understanding them so deeply that we can bend them to our will. From cleaner batteries to more sustainable materials, the future is all about mastering this backflip of chemistry. So, next time you bake a cake or just charge your phone, remember, you're part of the endless dance of reactions, forwards and backwards. And who knows? Maybe someday you'll actually see an unbaked cake. Now, wouldn't that be sweet?